So the sample set is what you're able to, the number, n of s is the number in the outcomes you could possibly get. So if we're looking to pick a card from a deck of cards, the sample set is the deck of cards, and the number in the sample set is 52. And if I'm looking for a black face card, so I can't write all those things in there, but there's the clubs and spades, and 3 in each, and so there's 6 total. And so the probability will be 6 out of 52. What's the probability when rolling one die of getting a 6? Well, there's 6 sides. So let's put a dice. Okay, so then you get 6 in the total possibilities, and there's 1 possibility of getting a 6. So that's 1 over 6. Okay, so then when we move to 2, we have to take into account that we can have different numbers on each of the die. So I made different colors just to emphasize that point. So we want a sum of 6. So let's see, I could have a 1 and a 5, or a 5 and a 1, right? The blue and gray, or the gray and the blue. I could also have a 2 and a 4, and a 4 and a 2, or I could have a 3 and a 3. So of the number in the sample space, that's going to be how many different possibilities there are for 6 for each die. So that's 36, right? So 6 squared, or 36. So the number in the denominator is 36, and the number in the numerator is this number here, and that's 5. All right, so if I want at least 9, that means 9 or more. So let's find out all the combinations of die that I could get that have 9 or more. So 5 and a 4, or a 4 and a 5, a 6 and a 5, and a 5 and a 6, a 3 and a 6, or a 6 and a 3, a 4 and a 6, 6 and a 4, a 6 and a 5, and a 5 and a 6. I think that's it. So that's 10 out of, again, the same total number, 36. So now I want at most 6. So that means 1, or actually the smallest you can get is 2, right? 2 through 6. So let's see, I've got 1, 1, 2, 2, 3, 3. And then I've got the combinations of 1 and 2, and 1 and 4, and 1 and 3, and then 1 and 5. And what else? I think I've got 2s and 4s, right? So all of those, there's 15 of those out of the possibility of 36. So if we're wanting to count the number of numbers, so how many numbers are in this list, we can count them, right? 1, 2, 3, 4, 5. So if I want an easier or a different way, if I want to have a larger range and not have to count them at all, this is, I want to take this would be the M, the smallest number, and N is the largest number. Then we use this little formula here. N, which would be 9, minus M, which would be 5, and add 1. And so that tells me how I get 5. All right, so here they're saying there's 73 consecutive integers. Okay, so that means 73 is, that's the number of consecutive integers. The largest is 89. So this 89 is like my N, right? So N is 89. And I want to find out what the M is. So that means 73 is 89 minus the M plus a 1. And so moving things around here, so 90, and then move the M to the other side. 90 minus 73, 17. All right, so then I want, it's going to just playing with it in a little different way. So the smallest of 61, okay, so I've got 61 consecutive integers, and the smallest is 61, so that's like saying this is N, so I want to figure out the, that's the M, I want to figure out the N, right, that's the M, and so then I want to figure out N, which is 102 plus 1. And so solving for N, I get 162. All right, so different ways of counting positive 3-digit numbers that are divisible by 5. And we'll kind of talk about a couple of different ways. I just want you to understand this method. So that would mean I'd start at 100 and end at 999. So the first three-digit number that's a multiple of 5 would be 5 times 20, 100. And I would go all the way up to 5 times 199, because 5 times 200 is too big. So I want to count how many numbers there were between 20 and 199. So 199 minus 20 plus 1, there's 180 of those in that list. So what's the probability of choosing a three-digit integer divisible by 5? Remember, probability will always be a fraction. So 180 will be the numerator of the fraction. And so what's the denominator? The number of numbers, or three-digit numbers total. So that would be 999 minus 100 plus a 1. So that's 900. So that's the denominator. Okay, so now let's do that same kind of thing that are multiples of 3. So two-digit integers this time. So the first would be 3 times 4, and I'd go all the way up to 3 times 33. So I'd want to count the number of numbers from 33 to 4, and so that gives me 30. So that's the number of positive two-digit numbers. So what's the probability that it is a multiple of 3? Again, that'll be the numerator of our fraction. And how many two-digit numbers are there? Well, 99 minus 10 plus a 1, right? Because the 99 is the largest two-digit number, 10 is the smallest two-digit number. So this gives us 90. That's your denominator. Okay, so this one's going right to the punchline. What's the probability? So you have to do both of them, right? I was kind of doing these examples, building it up. Okay, so positive two-digit integers that are a multiple of 4. So I start with 3 times 4, go up to, 3 times 4 and go up to 24 times 4. So the number of numbers would be 24 minus 3 plus a 1. So there'd be 22 numbers total that are multiples of 4. So that's going to be our numerator. And then we already figured out how many two-digit integers there are. That's 90.